Okay, good morning. Mr. Lesham is here, and today we're going to talk about number patterns. This is really just a recap from what you know from grade 10. Okay, we're not going to learn anything new here. We're going to focus, it looks like, just there at least, on linear and quadratic number patterns. Okay, so we'll start with this. This is a linear number pattern. What does it linear mean? It's what, sorry? Constant difference. Okay, so if I was to ask you what's the next term, what will be the next term? 19. Okay, and you say it goes up. Oh, hang on. I made a little bit of a mistake here. Let's say this is 3 really. Okay, right, goes up by 4 all the time. Okay, so the next one 19, then the next one 23, and so on and so on. Okay, but now then back in grade 8, I think we also learned that we can have this Tn. What does this Tn mean? It's the nth term. Okay, this is your first term, this is your second term, this is your third term. Then we have the nth term. Okay, and we want to have an expression for it. Okay, now how did we do it? We said, okay, first step, we're going to find how much we go up by. And we go up by 4. And I specifically write plus 4, because sometimes obviously we can go down. Okay? So we know that the nth term, I'm just going to use the same letters they use in the book. Okay? The nth term, I'll write it down here, for any linear pattern, okay, is Bn plus C. I used A last year, but I'm going to go with what they use in the textbook. Okay, that's the general linear nth term. Linear for linear patterns. What is n? Is n? It's just a number. It's an integer that starts from 1, 2, 3 all the way. What is b? How do you know what b is? What will be the b here? We're going to write it. It's something to do with n plus a c. What must I multiply n by?
4.
By 4. Okay, so in other words, B is your constant difference. Constant difference. Okay? If it's plus 4, it will be 4. If it's negative 3, it will be negative 3. And then C is what I call the correction. I call it correction term. Okay, that's just my kind of name. So you're not going to find in the textbook. Okay, C is another parameter, is another number that we need to find. How do we find C? What do we do to find C? Okay, what we're going to do is substitute for n equal 1. What is the first term? What is the first term in this pattern? 3. So we're going to use this equation, which is still not complete. Okay, we're going to say 3. The first term is 4 times what? What is n here?
3.
1. N is 1, right? Okay, for the first term, n is 1. And then the C, I still don't know. And now I can find that, okay, 3 equal 4 plus C. In other words, C equal?
1.
Minus 1. Okay? And now I can find out finally the nth term. I'll write it down here. Tn will be 4n minus 1. That's the nth term for this. Okay? I can check that. If I put n equal 2, for example, 4 times 2 is 8. 8 minus 1 is? 7. So it works. Okay? I'll pause here for questions. And there's 2 questions that I can ask you. Okay? So the one question I can say is, right, what is the 10th term? What is the 10th term? So I'm just going to substitute here, right? I'm going to say 4 times, what is n? 10 minus 1 is 39. Okay, that's easy, right? Now I can ask you, I'm just going to make okay, I can't copy them because I actually changed the thingy. So let's say, okay, which term is 79? I'm saying 79 is a number here, okay? We've got 79, okay? Which term is it? Okay, how much? Okay, so you did it straight away in your head, very good. But the way we're going to do it normally, we're going to say, okay, 79 is equal to 4n minus 1.
Plus the 1 and
You plus the 1, okay? Okay? Bruce already there in the head. 4n equal 80. In other words, n equal 20. So it's the 20th term. 79 is term number 20. You can only answer this, get that, after you find the expression for the nth term. That's why this is the main thing. You need to know how to find the expression for the nth term. I'll pause and we'll move to quadratic. Okay, so that was, can you see it? Yeah, that was pretty easy. That was a linear expression, or a linear pattern. Now we've got something which is not linear. How do I know it's not linear? It's not going up in constant numbers. So here it goes up by 4. Here it goes up by 7. Here it goes up by 10. Here it goes up by 13. So it's definitely not linear. But it is something we work with. It's quadratic. What makes it quadratic? Okay, the differences are not the same, but what can I do then?
The differences are patterns.
The patterns of the differences is actually linear. This is linear. So I'm looking at the difference. That's plus 3, plus 3, plus 3. So the difference of the differences is constant. Okay? Now, a quadratic pattern generally looks like this. This is a quadratic pattern. Okay? Quadratic pattern, number pattern. Okay? Quadratic, I mean, what does it sound like? It sounds like quadratic equation. In fact, it's very much related to each other. Okay? So you won't be surprised if a quadratic pattern looks like this: a n squared plus b n plus c. That should be very familiar to you. That's like in a quadratic equation. The only difference is that instead of x, I've got n. Okay? We can talk someday maybe about the difference. There's a slight difference between them, but we're not going to get into that. Okay? So every quadratic pattern looks like this. Just like every linear pattern, I'll write down here so you can see it, you can compare. A linear pattern, as we wrote on the board, on this side of the board, is we use b. bn plus c. That's why they're using b. Okay, now I get it. Okay? So a quadratic pattern have that extra n squared. And the question is, what we need to do is find the a and the b and the c. We're trying to find out the nth term for this. Now, last year I actually proved to you what I'm going to show you now. I'm not going to prove it again. If you want to, we can do it on the catch-up Monday, or you can watch my videos from last year. But what we said is that first of all, you get a pattern like this, while wrote in black. Then you do just like I did in green. Okay? And then you got to write down, or write in red, the following thing. You write a plus b plus c, and you circle. There's a little bit of a memory going on here. Okay? 3a plus b, and you circle. And then lastly, 2a, and you circle. This is something you just need to remember. Okay? When I proved it, I explained why this thing is, but I don't think it's going to help you so much proving right now. I'll do it grade 10, that's enough. For now, you just need to remember this. And you work it just like I do. You start with what they give you, you find differences, you find the differences, then you find the difference of differences, a plus b, c plus 3a plus b, 2a. Okay? What does this tell you?
That's the same for every quadratic pattern.
This side is all for every quadratic pattern. The numbers are going to be different. Okay? But you just got to remember this. This is the thing to remember. Okay? So what does this tell you? Okay? I'm looking for 3 variables, for 3 numbers, a, b, and c. So I need 3 equations. And these are my 3 equations. The first equation is 2a equal 3. Okay? Well, that tells you that a is equal to what? 3 over 2. Great. We got a. We nailed a. Okay? Let's write it down as we go along. Okay? So for this specific, this is the general quadratic pattern. This is for this specific quadratic pattern. We have 3 over 2 n squared. Now we want to find b. Okay, let's use this equation. 3a plus b equal 4. Well, you might say, but how do I've got a and b. How can I find b? We know a. Okay? So let's write down a. It's 3 over 2. So it's 3 times 3 over 2 plus b equal 4. equal 4. So in other words, let's see if you, okay, I'll write it slowly. 9 over 2 plus b is 4. That means that b is equal 4 minus 4.5. I think it's minus half. Just check me, please. Obviously, you can use a calculator. There's nothing wrong with the calculator here. But it's minus half, okay? Okay? All right, let's add it here. We nailed the b. Okay, so we know what the b is. B is minus half, so it's minus n over 2. Will you not be too confused, Faro? Because I could have said minus half times n. But you know me, I like just to put the n on top there. Okay, is there a question here? No. Just a big one. Okay, what are we missing? C. Okay, well, let's look at the last equation. A plus B plus C equal 1. But what are you going to tell me now? I already know A and B, right? I already know them. So A was 3 over 2. B is minus half, which is that makes it quite easy. So we can rewrite this equation. That's 1, right? 3 halves minus half is just 1. So 1 plus C equal 1. In other words, C equal to? 0. 0. So, I'm not going to have to write plus 0. It's not going to write it. That's the answer, guys. That is the answer. Okay, I'll pause here. So, we've done the hard bits. The hard bit was to find the term, the nth term. Now, the easier bit. Okay, they can ask you what's the 15th term. Okay, this is the first, the second, the third, the fourth, the fifth. What's the 15th? Now, I'm not going to go 6, 7, 8. It's going to take me too long. So, what do I do?
3 over n.
So, I'll do 3 over 2 times 15 squared. Just sub in this expression. Minus 15 over 2. And I'll just need, well, in fact, I'll pick up the answer if you don't mind. Hang on, you know what? Just a second. Okay, so we didn't do a mistake. I just did a different example. So it's all good. What was the answer for the 15? You said?
145.
Not the other question. The one before.
330.
Not
330. So hopefully we got that right. But it's fine, Simon. You can repeat again. What was the other number that I've asked you to find?
145.
Okay. So this was easy to find the 15th term. Now, and you didn't hear what I told you before, Simon found out that one of the terms here is 145. And the question is, what is n? Which term is it? You don't know. Yeah, I told him that quietly, okay? So how are we going to find which term is 145?
But we don't know n, sir.
We need to find n.
But
That's
we
all.
know n, sir.
No, we don't know n. This was the n15, gave you the 30. The term 330 is the 15th term. But now I'm telling you, I've got another term here, which is 145. It's obviously before 15. I don't know what n is.
Can they say 145 equals 3 over...
Correct. So what we're telling us, okay, just sub 145 instead of Tn. So 145 is 3 over 2 n squared minus n over 2. And now we know how to do that. That's a quadratic equation that we've learned how to solve in our first chapter. Okay?
That's it.
I'll just pause here. Yeah. So just to clarify, I'll actually repeat that question because, maybe I wasn't very clear on what the question was. The first question was they gave us a number pattern. We had to find the general formula for the nth term. The second question they said, okay, n equal 15. I'm looking for the 15th term. What is it, please? Substitute, we got 330. The third question, which is harder than the second question, is which term, in other words, what is n for 145? So we got 145 somewhere here. Hopefully, if Simon didn't make a mistake, okay, it's somewhere here. We need to find n. Okay, hopefully he didn't make a mistake. So how do we solve that? Okay, we've done stuff like this. What's the first step that you would do? I would.
Do you not substitute n?
No, but we need to find n. This is a quadratic equation, guys. Quadratic equation. Do you know what? I think the easiest
You
thing.
divide 145 divided by 3 over 2 to start off with, so then you get n squared minus n over 2.
Good. Does it come up nicely?
To make a trinomial, to what the moon is.
You know what? We can try. Let's try and do a trinomial. What I would maybe first of all do is multiply everything by 2 to get rid of these fractions. So I would say, okay, 3n squared minus n. What is 145 times 2? 290? 290. And if you don't mind, I'm going to minus 290 already in the back here.
Okay.
Minus 290. So move everything to the side and get an equal. Now, we can try and do a trinomial. It's going to be a difficult trinomial because we don't have a 1 here. So what should we use? Formula. Let's use the formula. I'll pause here whilst you're using the formula. Yeah, okay, so what maybe got you guys a bit confused is this quadratic equation. Instead of using x, I have an n here. Now, it's not exactly the same. There is a slight difference, but I'm not going to get into it. But as far as we're concerned, it's the same. So your b is what's in front of the n. Just like if it was what's in front of the x. So in other words, minus 1. So b is plus 1. What's 9? Plus 1 plus minus square root of b squared, which is 1 squared, minus 4 times 3, that's your a, times minus 290, divided by 2 times 3, which is 6. Okay? Right? Again, I'll pause and you guys tell me what you get here. You can just feed that into your calculator. I had a few difficulties here. One of them was that I forgot to time by a. So I actually add minus 4ac. Minus 4 times 3 times minus 290. And Finn eventually got it. The square root of this big number is 59. Okay? And then we divide it by 6. Now we're getting 2 answers. This is where you have to, and sometimes it's hard, you have to understand, you have to disqualify some of the answers. Okay, so the first answer is 1 plus 59 divided by 6, which is 60 divided by 6, which is 10. I don't know if you guys can see it. Okay, so one of the answer is, okay, n equal 10. Okay, that's good. That's in fact our answer. Right, Simon, that's the number.
Decimal, so it can't be.
Yep, and not just. Yes, that's one reason. So the other answer is 1 minus 59, which is minus 58 divided by 6. There's 2 things working against this solution. The first one is, as you said, is a decimal. I'm not going to even write what it is. 0, I don't know how much it is.
9,67.
So it's minus 9,6 whatever. Yeah? Now, n is an integer. N is 1, 2, 3, 4. It can't be a decimal. You understand? But there's another thing that works against it. What also can't, why also I need to disqualify it. It's minus. Okay? 1 is not in fact an integer. 1, if I'm more careful, I should say it's a natural number. It's what I call hide and seek numbers.
So that'd be
1, 2, 3. Okay? So you see, that's where you go through the process, but you have to sometimes cancel solutions because they don't make sense here. Right.
So
Thank you.
therefore
Let's
the
go,
term-
Exam.
So therefore it would be